and that these table exist. You have, this is an EC 2011, you're looking at table 310.15b7. 310.15b7 only used for residential, only for single phase, only for 24120. If you guys don't have these notes on this table, please write it down, a specific table only for residential, only for single phase, 12240. So please go ahead and highlight that one. And again, I'm going to start with the examples right away. So before I move ahead, I just want to make sure everybody knows how to highlight this. Okay, suppose, so here's the table that we're going to be doing mostly in residential. Suppose the building that you guys have with me, our building, right? Suppose our building came to be, here's my service coming, and here's my overcap protection device for each panel, right? Overcap protection device for each panel, overcap protection device for each panel, overcap protection device for each panel, 1, 2, 3, 4, right? Each one of these is a panel, and all overcap protection device for another panel. So suppose I have this system, right? Here's a system, one line diagram for a system, and I need to size everything for this system. I need to size the conductor for this system. Suppose, take this example. So this is going to be example number 1 for sizing. Take this example. Suppose this system was 480. Oops, we don't want 480 at this point. Suppose this system, let's go right into the different color. Suppose this system was 240/120 single phase, and this is a 400 amp panel. And suppose each one of these, this one was a 100 amp panel, this one was a 150 amp panel, this one 175 amp panel. These are amp. This one was 200 amp panel, and this one was 300 amp panel. Okay. Suppose that when you guys size the panels for me, 1, 2, 3, 4, 5. Suppose you came up with this system, right? A 400 amp panel, single phase, 24120, feeding 5 panels with the following amps. How do you come up with these amps? We're gonna do that for load calculation, guys. Why did I come up with 400 amp, not 1000 amp? That's called load calc coming later. So suppose you came up with, after you load calc, you came up with these systems, right? Residential, 240, 120, dwelling. Suppose you came up with this system. So what do I need from you guys? I need you now to size the conductors. Let's go size the conductors for each one of these systems. Okay, let's go size the conductors for the service. Based on this, my service is 400. Here's my 400. And right, here's my service is 400. I need to use copper. So I have 4 conductors. I want to be using 3 conductors. Number 400 kcm cu copper. Done. So sizing this system, residential only. Residential only. I can't emphasize this table is only used for residential. Only for single phase, only for 120. Special case. Very special case. That's it. I need three conductors, number 400 kcm, to bring the power. Why 3? 2 hots and a neutral. Remember, this is single phase. 2 hots and a neutral. Can I direct the neutral? Yes. Later on, we learned that the neutral doesn't have to be 400. I could have gotten away probably with 300 kcm instead of 400 kcm for neutral. But for this time, since we haven't done neutral calculation, we're just going to go full neutral. We call it full neutral. Any question, guys? See how easy that is? I size the conductors to match the overcap protection device ahead of this. So my panel is 400 amp. I size to carry 400 amp conductor. How do I know a 400 kcm will carry a 400 amp service? Right here, from this table. Everybody see the importance of this table? Very specific, residential only. Okay, let's go size the rest of them. So let's go to the second one. The second one is 100 amp. So for my 100 amp, I'm going to use for my 100 amp, I decided because I like aluminum, I'm going to use aluminum. So here's my 100 amp. I need 3 conductors. Number 2AWG. I'm just going to put the numbers over here, guys. So 3 conductors. Number 2 aluminum, AL. I decided to use aluminum. Okay, let's size the second one. The second one is 150. Here's my 150. We're going to use copper for 150 just because I have 150, I have number 1. So this one is going to be 3 conductors, number 1 Cu, copper. This one, it's used 175. 175 is the one underneath it. I'm going to use aluminum for this. 3/0. So 3/0. So this one is going to be 3 conductors. 3/0 AL. Are you guys with me? How to size them? And the rest is piece of cake. Let's go to the second one. Sizing a one-line diagram. That's what you do as engineers. We don't size cables for the sake of cables. We size cables to feed equipment. Does that make sense? So let's go size the last one. 200 amp. 200. What do you guys want to do? Copper or aluminum? 200. I like copper. Let's go 200. We'll cover 2/0. So I have 3 conductors. 2/0. The last one I like to do aluminum. The last one is what? 300. Here's my 300. I want to go all the way to the aluminum, right? 350. So 3 conductors, number 350 AL. Done. You size the whole system. Any question, guys? How to use this table? Where to use this table? Single phase, 120, 240, dwelling only for feeders and branch circuits. Now do me a favor. Everybody knows that this one here, what do we call this? This is service entrance conductors. Conductors, right? Everybody knows that this cable is called service entrance conductors. If you don't know that, probably you should. All the rest of these, how am I going to do that? All these are called feeders. Feeders. All these are called feeders. All these things that we size here and here and here and here are called feeders. So can I use this table for feeders and service? Yes. Can I use it for branch circuits? No. Feeders or service. How do I know? Because it says it here, single phase, dwelling services only, feeders and service and feeder conductors, and single phase 3 wires and 120, 240. Can I use it for 2/8, 120 single phase? No. Do we have 120, 208 single phase? Yes, it's coming from 3-phase system. Any question, guys, about how to use this table?
Do you normally keep the neutral the same size? Because there's some text about
If there's a neutral, here's yeah, I will tell you my rule, guys, later on. If you're neutral, now commercial, these rules are commercial. If your service is 100 amp or 200 amp or less, full neutral. Higher than 200 amp, we start derating the neutral when we do it in the commercial industrial. Residential 200 amp up to 200 amp, full neutral. But if you calculate the neutral list, you can derate the neutral. There is limit though, how far you can go, and we will do that. Any question, guys, how to use this table? My intention really is to know how to use this table. That very specific, yes, sir.
You use different kind of conductors.
Why did I use aluminum or copper?
Yeah.
But just because exercise. Just because of the exercise. You can either use aluminum or copper. Aluminum is cheaper. A lot of people tend to, not a lot, non-engineered projects tend to be more aluminum because it's cheaper, lighter, easy to work with. Copper is more expensive, heavier, and more safer though. Safer for copper.
So if you want to ask questions, you will tell us kind of.
If it's an engineered job, most likely it will be a copper job. Most likely. Though with the economy, people are moving towards, every time, if the project is cheap, not cheap, if they don't spend a lot of money, they go with aluminum. So take this. If you have a hospital, copper. If you have sport arenas, probably most likely copper. If you have a data center, copper. If you have a commercial building, sit somewhere, somebody want to make money by renting it out, most likely it's going to be aluminum. The firms I worked for, they specify copper only for feeders. Can I use any one of them? Yes. Any question, guys, about this table? I can't emphasize how important it is to use this table before we go into, this is residential. So, Rob, my friend, all the panels that you sized for me in this project is going to be sized based on which table? This table. Are we going to be using 310/16? 310/16, 310/15 B16? The other one? No. Everything that we're going to be sizing, guys, for me is going to be based on this table. May I move on that one? Okay, so everybody knows how to use this table? Okay, so the second one that we need to go, obviously, is the single most important table, which is 310/16. 3 10 to 16. You guys remember I told you how to use this table? I'm going to summarize them quick before I go into the examples. How to use these columns. I'm going to start by number 1. If the current I is equal or less 100, right? And this is I more than 100. You guys remember that rule for the termination? And this is amp, this is amp. This is rule number 1. Conductor is more, conductor is
Less.
a conductor is less or equal to number 1. You got that one? This is conductor more than number 1. You default to this. And right here also motors. Motors and also insulation. You have to have the insulation. Insulation is 75 degree or more. So this is how to use the 70 and 65. I know we went over this. These are very, very important topics to know. When to use the 60, when to use the 75. One more time. If the amp of the equipment is 100 or less, you default to 60. If the conductor is number 1 or less, you default to 60. If your conductor is more than number 1, or your equipment is more than 100, you always default to what? Unless you know otherwise. Unless they tell you the termination on both ends are rated for 75. So that's a rule. The question, since we're derating here, the question would be, when the heck do we use the 90 degree? Derating only. Derating only. And that's what we're going to be doing today. We're going to be sizing based on derating only. Any question, guys, about this? Okay, let's take an example, a quick example here, and we will get into that one. Suppose I have, here's example number 2. And suppose I have a feeder like this. My feeder here is 200 amp. And I need to size this conductor. It's a 3-phase feeder, 200 amp, right? Here, 200 amp feeder. So what's the 200 amp? Which column am I going? And by the way, if you don't know the insulation, see at your channel. The insulation is rated for 75. So what's the conductor? What conductor do I need for 200 amp? 200 amp, you're going to go to 75, 200 amp, you are right in here, 3 off. So I have 4 conductors, number 3 aught copper, CU. Copper, done. Take another one. Here's another example. Example number 3. Take another feeder. This feeder is 100 amp. 100 amp, I have no idea what this feeder is other than it's 100 amp. 100 amp feeder, nothing about the panel. I have no idea what the panel is. No termination 75. I'm going to go directly under 60 degree column. 60 degree 100 amp will give me what? Number 1. Number 1 will give me 100 amp. So I can, 4 conductors, number 1. Why 4 conductors? 3 phase and a neutral. Why 3 phase? Because these systems, I forgot to tell you, it's a 3-phase system. If it was a single phase system, it will be 3 conductors, 2 hots and a neutral. Does it matter which voltage? Does it matter if the voltage is 600 volt, 208, 120, 480, 277? It doesn't matter when you use this table, guys. The voltage is irrelevant. Irrelevant here. The insulation THHN is rated for 600 volt. So on the same conductor, I can pull 480, 600 volt, 480, I can pull 277, 120, the same conductor or conductors, 240, any voltage.
Under 6 or under.
Thank you. Yeah, because 6 or under, yeah. Yes, sir.
I don't know how you got that.
This one?
Yep.
Okay, so I have 100 amp overcome protection device. I need to match it. So you get number 1, can get you 110, you're good to go. Copper, we're doing the copper. Okay, so let's, before I leave here, I want to make sure also everybody knows the small conductor rule. No matter what, small conductor rule says number 14, number 12, and number 10 cannot carry, you cannot land them on a circuit breaker more than the following. So please highlight this, and these I already highlighted by the code for you guys, these two. These are small conductor rule. Small conductor rule. What does that mean? No matter what, you can't make a 14 carry more than 15 amps. No matter what. Land it on a circuit breaker more than 15 amps. One exception for this is motors.
And it isn't no matter what.
Huh?
And it isn't no matter what.
No matter what, with an exception. Okay? For exception is motors. Motors are a very big exception. You're going to see that. Okay. So please highlight that 10, only these special. Anybody knows why they do that? These are between these three sizes, guys. You probably the branch circuits, lighting and receptacle branch circuits. Between these, probably they cover 95% of all your branch circuits, commercial, residential, or industrial. 95% of your branch circuits, lights and receptacles are covered from these three sizes. So these are the most commonly used. So they try to kind of limit because if it's used, it's abused. Because it's used a lot, it could be abused also a lot in residential or commercial. You can add a couple of receptacles here and there. So they want to caution you. If you look at number 14 can carry a whole lot of amps, guys. Can carry at up to 25 amps, but we're limiting to 15 amps. We're cutting it by almost half for safety. Any question about the rules for this table before we start sizing? Okay, you're going to grab this table now. Make sure you have the table handy in front of you, and let's go size first without before we move ahead, guys, the ones who had the calculator, grab your calculator, would you? Grab your calculator and put it right in here. Here's my calculator. Okay, so the first thing we need to do for your calculator, guys, everybody has calculator. We're going to go set your calculator to 75. Set 7. That will set my calculator 3-phase 75. 3-phase 75. Okay, 3-phase 75. I need to go size a conductor for a 200 amp panel. A conductor for 200 amp panel. 3-phase. Now remember, it's a 3-phase. Can you guys see that says 3-phase right here? 75 cover. 3-phase 75 cover. I decided to use cover. Like the one that we did, right? We use cover. So okay, here's 200. Put your 200, 200, and put your amps. This is my amps. Can you guys see where it says wire size? 3/0. What did we get here? 3/0. One more time. Clear? Clear. I'm doing example number 2 with the calculator. I need 200 amp, regardless of the voltage. Regardless of the voltage. 200 amp, hit the amp, so it identify as 200 amp, and hit the wire size, and off it goes with 3/0 cover. If you hit it one more time, it will tell you how much amp the 300 can carry. If you hit it one more time, it will give you the KCM for it. I'll hit you one more time, it'll give you the table, where the table came from. Isn't that cool? Where it came from, which table it came from. So you can review your work. That's very slick. Very slick. On my test, guys, calculator enabled. If you know how to use the calculator, be my guest. Any question, guys, about this? Now the 100 amp might default you. Let's use the 100 amp. Now the 100 amp, remember, it's unless you know otherwise, it's going to default you to what? We size here based on 60. So I'm going to go change my calculator to 60. So set your calculator to 60. See if it sizes actually for you based on 60 here. Close it. So I default it to 60. Everybody see can default it to 60. Let's go 100 amp. Here's my 100 amp. And here's the amp. Now I want to hit the wire size. I should come up with number 1. I hope so. Number 1 cup. But did you see what I did though? I changed it to 60. Now let's go see if I know that termination are 75. So I want to go change it to 75 and see what I can get. 75. I can get number 3. If I size based on 75, I can get number 3. See how nice the calculator doesn't make you smart. You have to know what you're doing. The rules that I sit there, you have to know it. But because you have to switch the calculator, guys, right? But when you know that 100 or less, you default to 60. Now say I know my equipment is rated both ends like in commercial. If we're in a commercial, 90% of these panels, guys, are rated for 75 on both ends. So I size everything based on 75. Look what I did. I just switch set 7, set it on 75. It gave me 3 cover. 3 copper. Any question, guys? Okay, so that's the slick. I'm not sure if it can do the residential table though. Let me go close my email. Close window. Okay. So this is just how to size it. I want to take close this one here and take a couple of more examples as we go. Okay. Let's go here. Technology here. And let's go my calculator here. Okay, let me take one more example. I want to parallel. I have a 4,000 amp switch gears. I'm going to parallel. Do you guys have a problem with that? I want to parallel. I have a 4,000 amp switch gear. I want to parallel it. Let's take this example. Example number what? Example number 4 now, right? We're at example number 4. If we keep track of examples. Let's take this. Let's take a panel that Chad have decided to do 2,000 amp panel. You guys have an issue with that? 2,000 amp panel. And from the 2,000 amp panel, I'm feeding a 600 amp panel here, and a bunch of others too. There's a bunch of others, and I'm going over here. I want to give myself enough room here so I can do the work. So this is my first panel. Here's my second panel. This is also, it doesn't even look like an overconduction device. First, what did you do? Okay, here you go. Okay, now let's do a 400 amp. Okay, I have a 400 amp and a 600 amp fed from a 2,000 amp. This is a 2,000, believe it or not. Now it's a 2,000, right? Let's go size it. 3-phase. What voltage? Care less. I care less about the voltage. Let's just say 3-phase for the heck of it. I say 3-phase, and the voltage is V equal or less 600 volt. See why voltage, this application can get you all the way up to 600 volt, 28, 120, 480, 277, 600, 345 or something, 28, 240, 120, 3-phase, delta, any voltage, up to 600. Okay, let's go size these. Size the conductor. So what's the question is? The question is, would you please find 1 here and find 2 here and find 3 here, which is basically the cables. Size the cables. Could you please size the cables for these one-line diagram? And oh, by the way, all these are inside one box, right? This is all one box. So I have a feeder, and that box, I guess you can put the overconduction device. Most likely is going to be the box is going to go right there in real life. So the overconduction device is going to be inside the box too. Okay, so here's there you go. So here's my panel, main panel feeding all these babies. Okay, let's go size it. So the first thing, if you guys go to the NDC code book, all of them are 600, 400. So default is where? Where's my default? Default 75. So if you guys go to 75 and I need the 400 amp, my 400 amp at 75, I can use 600 can give me 420. So okay, let's use it for the 1,000 for number 1. Let's go number 1 first. Number one, I have 2,000, right? I decided 2,000 amp. I decided to parallel 4 sets. Why 4 sets? 4 sets give me 200. Then I'm gonna go up to, so that will give me 200 amp. Okay, from 200 amp, guys, if you go to 310.16, 310.15b16, 310.15b16, this table, what would the 200 give you guys? A 200 amp under 75, 200 can give me 3 aught. So this is 4 conductors, 3 aught. Copper, of course, CU, copper. Yes, sir.
How do you get 200 there?
Yeah, I don't understand.
Isn't there 550,000 divided by 4?
Did I lose it? Did I lose it? Sorry,
Oh, right.
10. I divided by 10. I'm going to take 10 runs. Thank you. I said, where the heck did you kill? I divided by 10 to give me 200. Why 200? Because 200 give me in the odds. You look at the table. Can I parallel 12 sets? Yeah. Can I parallel 8 sets? Yes. No problem. Thank you. So I just want to target the 200. So that's why I picked up the 10 easier.
Chad, could you explain how you're paralleling from the 2000 to?
Give me, yeah, I will in a second. You have a good point. So here's my paralleling switch gears. Then if you guys go here, you're going to get the following. So I have 10 sets of 4 conductors, 3 aught each. So you're going to have 10 sets, 4 conductors, 3 aught each. What does that mean? A lot of wire. What does that mean? This means when you parallel the switch gear, when you pull your stuff, here's your conduit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a lot of work, huh? Imagine installing this system. Here's all my conduit. Here's 10 conduits. 10 conduits. Inside every conduit, the following. Inside each conduit is the following, my friends. And you can use imagination for the rest of it. Inside each conduit, they're similar. Here's one conductor, phase A. Here's phase B. Here's phase C. And here's a neutral. And these are your 4, did we say 3 aught? 3 aught CU. And 10 runs in parallel. Does that make sense? Does that make sense? So you have 10 conduits, each one of them carrying 4 conductors to parallel to carry this 2000 amp switch gear. Okay, now I didn't answer what parallel is. Still, paralleling, guys, you take the end of every cable at the end. Let me just grab phase A, because otherwise it'll be a mesh. Here's a phase A. Let's the blue. Yep, let's go phase. Here's one phase. Here's another, the same phase. Here you can see the same phase coming out. Just one. I'm going to show one phase, otherwise it will be a disaster. One phase. All these phases, each one is landing on the same switch gear with lugs. Can you see how each phase is landing on one lug, the same phase? So you took one phase from every conduit and you land it on one lug inside that bar of a switch gear. Now imagine 4 of these. One for the red, one for the green, the black, and one for the green, the neutral. And that's from this end. From the other end, I'm showing it from one end. From the other end, the same thing, guys. So you took it, here's my end, and please use imagination here. From this end, the same way, coming and tying. There you go. And from this way, this way, this way, this way, and this way. And they're landing on another log from this side. So from the circuit breaker side, you have all these lugs for the cables to hang on. And on that, in the top and on the bottom, 500 feet away, you have the same set of lugs, 10 of them, so you can land all the cables on both sides. You guys, are you with me? When you take, imagine 10 of these, one side, each side have its own lugs tied, and 10 of them, and all tied at the end. That's what parallel conductor is. When you parallel conductors, if you don't know by now, the conductors have to be the same length, so you have to measure them. Has to be the same size when you parallel them. So 3 aught, they all have to be 3 aught, the parallel ones. They have to be the same insulation, the same conduit type when you parallel them. If you put them in different conduit, what else are we missing? The same type, we said the same length, the same size, the same type, the same insulation, and the same conduit. If it's
So when you're cutting the lengths, you have to account for you probably have slack in some and no slack in others.
yeah. But you can be off, it doesn't have to be identical, but you can be off with a foot or two, but you can't be off with the 25 feet in one run. Yeah. Okay, so that's when we parallel. So all these blue lines that tied at both ends, the blue lines that tied at both ends, they have to be the same size. They have to be the same type, copper or aluminum. They have to be the same installation, THHN, all of them, in the same type of conduit, rigid or EMT, and the same length. And the same length. I have a feeling we are missing something.
Don't you have to derate if you have more than 3 conductors in a pipe?
It's a neutral. Now the neutral, is the neutral carrying conductor current or not? That's a different story. We'll leave it. We'll leave it until we're assuming it's not carrying current. Okay, let's go do this in the calculator, would you? Do the same example on this calculator. So I have 4,000. Everybody cool? So what did we come up with? I want to remind you, we came up with these sizes. So the first thing you need to do, you need to set your calculator. Can you guess it? Is set at 3-phase 75 copper. Everybody's there? Hit clean, so you can clean it. And let's go to our 2000 amp. Here's my 2000 amp, 2000 and boot amps. Does it matter what the voltage is? For all sizing right now, no voltage drop, nothing. It really doesn't matter. So you can put the 480 or 280, doesn't matter the size. So I need to go and size the wire. Okay, so hit wire size. It will tell you none. There is no one conductor can carry this, right? That's when you're going to ask yourself, I want to parallel. How many sets you want to parallel? Let's just do the example. I want to parallel 10. So hit 10. 1, 0. Okay, cool. After you get the none, no wire, are you losing it? And you hit, see where it says parallel size, PAR size, parallel size. And what do you get? 3/0. Do you see it? First you hit the wire, it gets you lost it. Then that reminds you that you have to parallel, and then you go ahead to your parallel. You can go direct to parallel too. Yes, sir.
What if you did not, excuse me, if you didn't use 10?
I changed my mind. I'm going to use 12. You guys? I changed my mind. I want to use 12. Go right here. Go type 12. I changed my mind. I want to use 12. And hit parallel again. 2/0. I changed my mind. I'm going to use 6. Hit 6 and parallel. You get 400 kcm. Does that make sense? 6 runs of 500 of 400 kcm cover. Any question, guys, about this? Is that powerful or what? Cool. But obviously, what we did is we did 10 of them. So here's my 10 and parallel conductor, and end up with 3/0. 3/0 copper. Now I change my mind. I want to go aluminum, right? So all what you do is you sit right on the spot. Sit here and change it to aluminum. 250 amp, 10 runs. See, right on the spot. Phil, what you can do is you can blend and look at your scenarios. That's what I like about this calculator. Not just give you the right answer. It allows you to run scenarios. What if I will parallel 10? What if, and instead you can do that on a piece of paper. What if I change my mind? I want to do aluminum. So I change my mind again. I want to go back to copper. Set and hit the copper again. And off it goes back to 0, 0, 0. 3/0. Any question, guys?
Yeah, after you parallel, to get the right amount of amps for those panels, like 600 amp, right? And then 400 amp, you just have to bring in, so many of those conductors into that.
Yeah, they're sharing the amps. So for example, the 2000, the 2 runs, each conductor will be carrying 200 amps, 200 amps, 200 amps. When you add up at the bus, they added 2,000 amps.
So you need 3, and we're just talking about one wire here.
Oh, we're talking about one phase. Yeah, you will be having 3 phase.
Yep, so in that 600 amp panel, there would be 3 blue, according to our example, 3 blue.
Yeah, 3 conductors, 3 phase A, phase B, phase C, and a neutral.
Okay.
Let's do number 60 amp and 400 amp. Okay, shall we do a 60 amps, 600 amp? Now I have two more panels I need to do. This is for number 1. Let's go do it for number 2. Number 2 is at 600 amp. Let's go directly to number 2. Number 2, guys. Oops. My number 2 is 600 amp. I have a 600 amp. Should we parallel? When do you parallel? Usually, if you can carry something with 500 kcm, my rule, don't parallel 500 kcm. Can I carry 600 amp with 500 kcm? No. Then a good idea so the electricians don't curse at you and give you the finger as they pull these conductors. Parallel. Okay, so let's go parallel. How many sets though? Don't go nuts. You cannot parallel. The rule that I forgot about paralleling, you cannot parallel less than number 1 out. Can I parallel number 2, number 12? Believe it or not, yes. Only for control. But you can't do it for power. For control, yes. But we're not doing control here. For power, no. The smallest that you can parallel is 1 out. Okay. So because of this, I'm going to go parallel 2 sets. I think 2 sets is good. That will give me 300, right? Did I do my math right this time? So my 300 amp, take this one to 310.15 B16 under 75-degree column. Why 75-degree column? Because we are higher than 100 amp. So that will get me, where are my calculators here? That will get me, what did they say I need? I need 300. That will get me 350, right? Everybody got 350? So 3 conductors, 350. KCM, copper, CU. Let's use a calculator to see if we can come up with that, just that size. Okay, so hit. Okay, so use my calculator. I need, remember, I'm sizing for 300. Here's my 300 amp, and go wire size. 350. So give me 350. My calculator also gave me 350. Right? Cool. 350. Okay. So what did I do here? I had 2 beautiful conduits here. 2 beautiful conduits side by side, and I'm pulling inside them phase A, phase B, and just to give you an idea how it's going to look like, and phase C in both of them, and then neutral. You guys have issue with that? Here's the paralleling. And what do you do at the end? At the end, you tie these 2 together to the same log. In both ends, tie these 2 together, and tie the blue together, and don't forget to tie the black together on both ends. So the other end here, where's my black here? Here you go, tie together, same logs, and then you take the blue again, the blue with the blue, and the red with the red. And again, they're tied through logs, guys, and the green with the green. The green in both ends with the green. That's what paralleling is all about. You tie them at the end, at both ends of the cable. Okay, so let's go. So this would be, the way you write it, it's going to be 2 sets of 4 conductors, 350 kcm each. CU, cover. Just use a calculator to come up with this. So suppose that, clean your calculator. Suppose I have 600 amp. Here's my 6. 0, 0. Does it care the voltages? No, care less. Here's a 600 amp, right? My amp is 600 amp. Let's go find the wire. Now, if you hit find the wire, it will give you 1500 CU for it, right on the spot. There is a conductor that can carry 1500 CU. You'll put in a conduit. Good luck pulling that boy. You can. Why would they give you a size, guys? Otherwise, cable trays. You can put them in a cable tray, open cable tray, lay them down and tie them. That's why they give you a size. No, I don't want this. So I need to parallel 2. So hit 2 and hit parallel. That will give you 350. Okay? So see, wire size, if you give none, meaning it doesn't exist, you have to parallel. You have to parallel. But it give you a size, a huge size, and you say, are you kidding me? I don't want to go higher than 500, maybe 600 kcm. Then when you get higher than 500, 600 amp, go back again and hit how many sets you want. I had 2. And that will give you 350. Suppose I change my mind. I want to have 3 sets. Here's the 3 sets, parallel. 3 sets of 300 CU. Change my mind, aluminum. I'm going to go aluminum. Okay. Change this. It'll give you 250 aluminum. 3 sets, 250 aluminum. Back to my example, because I used 2 sets. I'm going to go back to and parallel. Okay. Oh, that's aluminum. I don't want aluminum. I want copper. And it give me 350 copper. Yes, sir.
I don't know what time you need to use the set. How do you determine what what set you use.
How many sets do you use and what do determine the sets that you use? When you parallel, always look at something around the 500 kcm. So why did I divide by 2, not by 3? I want, okay, first of all, start with 1. 1, it's a big conductor. We know if you divide by 1, 600 big conductor. Start with 2. 2 will give you 300. Go back to the book. What is 300 can give you? If you go to the book, 300 give you 350 kcm. Is this a good size to pull? Yes. Why? Because it's 500 or less. Stop. So if you divided this, say you come up with a number here, 700. Go back to 700. It will give you a bigger conductor. So really, to give you a cutoff, here's what your cutoff. If you're looking at an answer, if you come up with more than 380 amps here, 380, you might have to go one number. So suppose I came up with 380 amp here, that will give me 500 conductor. Good. Higher than 380 amps, where's the 380? If you go to 500 kcm under 75, it'll give you 380. So remember that 380 is your cutoff here. Higher than 380, you might have to add another set. Add another set. So there is really not black and white. I use the 500 kcm. Here's my 500 equivalent to 380. Every time I get 380 or less, I'm cool. If I get higher than 380, I might have to run another set. Any question, guys? Let's do the third one. We haven't derated yet. This is just straightforward sizing. Straightforward sizing. Okay, let me do the last one, guys. Number 3. Number 3, what was the size number 3? Number 3, what was it? 200 amp or? Can't remember. Back. I have 400. Okay, I have 400. The last one, guys, is a 400. I have a 400 amp panel, feeder. I need to size it. Okay, no problem, Chad. 400 amp. If you take 400 amp directly all the way to 310.15B16 under 75-degree column, will give you 600. 3 conductors, 600. Let's do the calculator right on the spot since it's here. Here's my 400. Let me clear. Start new, 400, 00, hit wire, copper, 400, see. Did I do 400 copper? Oh, I'm paralleling. Am I still paralleling? What am I using? 75 copper. I have 400. So, okay, wire size. It's giving me. I'm not hitting amps. Thank you, Chad. 400. Thank you. 400. Hit the amps. Now we have 400 amps. Now let's go to the wire. Wire size 600. Thanks. 600. So we came up with 600. Disclaimer, the code allows you up to 800 amp, guys. Allow the conductor to have a slightly less amp than the overcome protection device, if it's an X standard. Based on this rule, you'll see a contractor fail that use, based on that particular rule, you see a contractor use 3 conductors. I'm sorry, this should be 4 conductors with a neutral. 4 conductors, 500 kcm. Based on this rule, you will see some contractor using, is this okay to use 4 conductors, 500 kcm? Yes. What is the 500 kcm, guys? If you look at how much amp a 500 kcm can give you, a 500 kcm can give you 380. Ask yourself, what is the next standard overcurrent protection device? What's the next standard overcurrent protection device? How do you know where they are? 240.6. You're going to go to the NEC. If you go take the 380 to 240.6, what's the next overcurrent protection device? If you guys look at the code, it's 400. Based on this rule, you could have gone with 500 kcm. And you see that in some contractor do that to save some cost. Good engineer job, you use 600 kcm. Okay, so the calculator will get you 600 kcm. Any question, guys? Any question about that? So these are four conductors. We're not derating yet. Four conductors. We're not derating. 310.15B16. Any question about that? So on the test, which way are you going to do it? You're going to do it the top way, the blue. Can I do the bottom? If you do the bottom and you tell me the code says up to 800 amp, your conductor can be slightly less than the amp of the overcurrent protection device ahead of them, you're okay. So I changed my mind. I'm going to go aluminum. Let's go change and set this one and see if we can get an aluminum. 900 AL. Bad idea. Too big of a conductor. I want to parallel. Too big of a conductor. I want to parallel, right? So let's go 2 and hit parallel. Now you get 250 aluminum. 2 sets of 250 aluminum for this 400 amp. Aluminum. 2 sets of 250. Now you want to know how much current this set can carry. I think if you hit this 900 aluminum, I think if you hit parallel, none. Okay. What did we say? 2 and parallel. Hit parallel again. There you go. If you hit parallel again, guys, it give you 205. Hit parallel again. Aluminum. Hit. It keep bouncing between the amps and the size. Can you guys see that? This is the amps, and this is my size. 350. Okay, obviously I did copper, so I'm going to go back, set it to copper, and I paralleled how many sets? Did I parallel? I didn't parallel, so I went directly wire size. I went directly wire size to 600 kCU. Any question, guys, about this? Any question? Let's go the rate. Now, Rob, my friend, 99% of the time, this is how you should be sizing. Cable, 4 conductors maximum, and 1 cable for feeders. Done. Don't group things. Feeders. Right? That's the best way to do it. From an engineering point of view, 1 cable, 1 set of cables, and 1 conduit, and shoot it off from point A to point B. Don't group feeders. Bad idea to group feeders. Feeders. I'm not talking about branch circuits. Feeders. Okay. Now, what if we have to derate based on temperature, because we're in the middle of the desert in Arizona, and we're pulling this feeder? What if we have to derate based on temperature and or based on bundling? Only a fool will bundle these things together in a conduit. It's really feeders. But temperature could happen easily, right? I could parallel these. In this case, I'm not paralleling, but I could have 10 sets on the top of the roof going to an air handling unit, right? I could have that one outside, temperature, ambient temperature is high. So I could have a situation like this.
Wasn't everything bundled that we looked at? They were always 4 wires.
4 wires, the neutral does not count if it's carrying the neutral. If the neutral is carrying the unbalanced current between the 3 phases, count as big fat 0. Okay, and that's the case, guys, when you come to feeders. When you come to feeders, feeders, not saying branch circuits. So you talk about 100 amp or higher. When you come to 100 amp or higher in 3-phase 480 277 or 28120, the neutral is really in reality carrying only the difference between all these, and it for all practice, code wise, it will count as 0 in terms of current. So you're really looking at 3 conductors. Yes. Feeders. Okay. I'll get you to the omitting a neutral calculation. 220 dot something here. I usually do a neutral calculation, guys, later on, but determining existing buildings. Look at 220.61 for neutral calculation. Feeder and neutral. A feeder or service neutral load shall be the maximum unbalance of the load determined. The maximum unbalanced load shall be a maximum at calculated load, blah, blah. For 3-phase, 2-phase, okay, 5-wire, permitted reduction. Feeder service supplying a house electric range and prohibited reduction. We'll go through the calculation, guys, on feeders. Okay, so that's for feeder calculation. 310 neutral. I'm sorry, the one that talks about Chris, the one that talks about the neutral doesn't count is actually in page 152. Does that help you? Yours is different. It should be it should be 310.15b4. It says neutral. A neutral conductor that carries only the unbalanced current from other conductors of the same circuit shall not be required to be counted when applying the provision of that table. Everybody's there, guys? Page 152. That's why I didn't worry about the neutral. If it's carrying the unbalance between them, which is 90, there's harmonics, but that harmonics is a big deal, guys, on branch circuits, not on feeders. Not on feeders. Okay, let's go. You guys need a few minutes because I need to do the rating. Anybody wants to stretch a little bit? Shall we stretch for 5 minutes because I'm going to go until 11. Let's stretch that way. Okay, there is a major concept now we're going to talk about, guys, is derating. Size based on derating. If you listen to what Chad is going to tell you, you would never have sizing and derating wrong again. And I know a lot of you guys know with Chad, we derated. The way I do derating, guys, I look at it from a design point of view. Derate, we only derate to size things. We don't derate for the sake of derating. So I'm not going to tell you derate a conductor, how much amp can this conductor carry. When you derate for the size of equipment, you always start with the load. So let's go ahead and start with a couple of loads and size. First, based on no derating, and second, based on derating, and see how we come up with a different aspect. Okay, so take this. Let's do example number 5. Is that example? Example number 5. Example number 5, and I always like to start with a system like this from now on, guys. This is my load. Here's my load, and I take this. Here's my load. My load here is 43 amp. I bought a 43 amp machine, and I need to size the overcome protection device for this machine and the conductor. The overcome protection device for this machine and the conductor. Overcome protection device and the conductor. So here's what do I need to do? I need to size number 1. This is called overcurrent protection device. This is called conductor. Course, as you guys know, or feeder. I use the term feeder. Feeder. Okay, so I'm going to call this one. I'm going to call this one number 1, and I'm going to call this number 2. Okay, so I have machine, right? That's what, in reality, that's what you're going to get. You get a machine, and you need to size a fuse for it, and a cable, and tie it to it. Now, here's my question for you guys: is this single phase or 3-phase? Let's do this machine as single phase, and let's do it as 3-phase. Okay? In this case, it really doesn't matter what the phase is. It's 43 amps. Look at the 3 amps. 43 amps. Is it less than 100? What's the rule if it's less than 100? 100 or less. 60-degree default. Now, you're going to ask me, Chad, is this non-motor continuous load? This is non-motor continuous load. So let's assume this load right next to it, non-motor, and it's also continuous. Continuous. So what does non-motor means? Does it have a whole lot of motors in it? What does non-continuous means? A continuous means it runs for 3 hours or more. Cool? All right, let's go size number 1. Number 1, the feeder, if it's continuous load, guys, or conductors, if it's conductors, you need to, by code, 1.25 times the full load current, which is 43. Why 1.25? Because it's continuous load. So you take 1.25, 43 times 1.25, you're going to end up with 54 amps. 54 amps. No problem, Chad. 54 amps, 54 amps. Take this one to 310.15, B16. Which column and why? Which column and why?
60 degrees.
60-degree column. Why 60-degree column? I have no idea what the lugs on both ends. Do I have any idea about the lugs? Are they rated for 75? No. If they tell you rated 75, you do it. If you don't know anything, 60-degree column. Anybody can tell me what's the answer for this baby? From 60-degree column, 54, 55, number 6. Number 6. Is it single phase? So it's going to go number 6. Now the question would be, is it single phase, Chad, or 3-phase? Does it need a neutral or not? If it's single phase, no neutral, 2 wires. If it's single phase with a neutral, 3 wires. If it's 3-phase with a neutral, 4 wires. If it's 3-phase only, 3 wires. Everybody knows these combos? 3-phase only, 3 conductors, phase A, B, and C. 3-phase with a neutral, 4 conductor, add the neutral. Single phase with no neutral, 2 conductor, hot 1, hot 2, 2 conductors, right? We're not counting the ground, because it could be the ground, could be the EMT conduit. If it's single phase with a neutral, 3 wires. Why? 2 hots and a neutral. Do you guys see how right here I can put any number of conductor based on the system that I'm dealing with? Does it matter what the voltage is? Really, for all practical reasons, the only right here I can put the voltage equal or less than 600 volt. Any voltage system that you can imagine here. Okay. So let's just, for the sake of doing it, since we're doing single phase, let's just do this is a single phase system. Single phase, so that will be 3 conductors with a neutral. How do you know if the machine need a neutral or not? You really don't. You're going to read if you don't know the machine need a neutral, the only way you can get if the machine need a neutral, if it's 240, for example, is it 240 only or 240 120? If it says 240 120, then need a neutral, if it's single phase. So you have to basically look at the nameplate of the machine. Now, what is this amp? This is the full load current of that piece of equipment, that non-motor that I have. Questions? Done. We sized it. Let's go size the overcurrent protection device. Number 2, overcurrent protection device. Overcurrent protection device, guys, if it's continuous, the same 1.25 times the same calculation, 43, get you 54 amps, except I'm going to try to use the same. We take this one to table 240.6. If you have not been in 240.6, please go there. It has the list of all the overcurrent protection device. Or if you don't like the code, which you're in trouble if you're in the wrong industry if you don't like the code, DeWalt also have them in 3.13. 3.13, DeWalt has all the overcurrent protection devices. These, Ashley, these are all non-adjustable overcurrent protection devices. Means what you see is what you get. 100 amp is 100 amp. I can make 100 amp 50 amp. Okay, so what's the next standard? 50? Do I have 45?
Yeah.
Do I have 45? So my next standard will be 45 amp. 45 amps. Any questions about this? Start with the load. Start with your load and go all the way to the machine. Okay, let's go use the calculator.
You can't use 50.
And what? 54. I'm sorry, 54 amps. No, this is. What am I doing here? 60. This is your answer, right? I thought 44. This is 54. That will give me a 60 amp. 60 amp of user circuit breaker, right?
Next size up.
The next size up. So can you write to yourself? This will be next size up. Next size up. You go next size up. 60. Any questions about this? Now Phil is good.
Okay.
In DeWalt,
13.
in DeWalt it's page 3-13. 3-13 in DeWalt. 3-13 in DeWalt. 3-13. 3-13 DeWalt. Okay. Now, Phil, my friend, why do you think they do it this way for the overcurrent protection device? Do you guys remember the continuous if you have a circuit breaker, you cannot continuously load the circuit breaker more than continuously 80%. You can't load the circuit breaker more than 80%. By doing it this way, I'm guaranteed, Phil, my friend, that I'm not loading my overcome protection device more than 80%. Right? Because what's the 80%? 80% is the reciprocal of 1.25. If you start with the load, multiply it by 1.25, you get the overcome protection device. If you start with the overcome protection device, times it by pointing it, you get the load that you can pull out of it. The reason why I always start with the load, guys, Rob, you're a designer. You only start with the load. You don't say, well, here's a circuit breaker there, find me how much current you can pull out of it. You are designing the circuit breaker. I mean, you start with a load, because that's what we're going to put in this building, and we build the building. We build the system by having feeders and overcome protection devices.
Now, is that a branch circuit or is that a?
This is, technically, this is a branch circuit. This is a branch circuit. Yeah, I should. The difference is, the branch circuit is between the last overcome protection device utilization equipment. So this is technically, let's use a technical term, you're right. Technically, this is a branch circuit conductors. For all practical reasons, the calculation is the same. It's just, but
you could use a different table if it was a feeder.
no, the same calculation. Yeah, same calculation. Now, yeah, the same calculation. The only time we use the table is for feeders, is for, this is not even here. This is for the service and the feeders. The residential service and feeders, specifically for feeders and residential.
That's why I asked what are the-
Yep. Good point. Let's go size this one from the calculator. Why did you guys spend some good money on this calculator? Okay, first of all, go set yourself to single phase, would you? Set single phase. When you go to single phase, and make sure you're at 60 degree. So here's my 60 degree. The most important thing, I'm setting myself at 60 degree. Why did I put myself at 60 degree? Because look at my amps. My amps, so that, see how the calculator is really not replacing you? You still know what to do. You still know the amps are less than 100, so where do I need to go? 60 degree column. So set your calculator for 60 degree. Because Chad is cover lover, so we're going to put ourselves at cover. Everybody knows how to set 60 degree cover. Now let's go size the amps. How many amps do we have? Now, here's where I want you to wake up. If it's continuous load, all what you have to do is just hit the load. What's the load? The load is 43, so 4 and a 3. Are you with me, guys? Just the 43 and hit amps. Okay, so I have 43 amp load. Because it's continuous load tau, my friend, all what you have to do is hit set. This is slightly different. Set and wire size. It will size the wire based on continuous load. If you guys hit set and wire size, it will give you the wire size based on 125%. Can you guys see right above the wire? There's 125%. You do this one if it's continuous load. So did we come up with number 6, right? Isn't that what we come up with? Yeah. Number 6. Isn't that nice if somebody agrees with you at least? No, thank you. Overcome protection device, at this point, you're on your own. The overcome protection device, guys, you're on your own. For this. We're going to be using them inverse type circuit breakers for motors. For motors, they are here. But for this type of calculation, which is, what's the difference, guys? Overcome protection device, just continuous load. You take 53, go up. Done. Any question about this? Any question about this? Now, suppose this was not a continuous load. Look at the difference. Now, I want you guys to wake up. Suppose that this was not a continuous load. And I'm going to do it right on it with a color. Which color have we used? Red. So for you guys, you probably, suppose that this was not, it says continuous load, non-motor, the same thing. I'm going to do another example number 6, right at the top of it, so you can see the difference. This is also non-motor, non-continuous. Non-motor, non-continuous. Are we with me? We're going to do the same example. Had it been non-motor, non-continuous. Non-motor, non-continuous. Not continuous. Does it run for 3 hours or more? Non-motor. There's no motor in it. piece of equipment. Okay, so here's the change. I'm really writing it right at the top of it. No multiplication. You take the 43 amps. No, that's it. No multiplication with anything. So you take here 43 amps all the way to 3 10 to the 16. What do you get? 3 conductors number for 43. 43 amps. 40, 40, 43, number 6. Oops. We're still at,
Yeah, you get to 6.
yeah. We're still at number 6, right?
Yeah.
54. Yeah, we're still at number 6. So number 6. It didn't change the size. Still at number 6. Now the overcome protection device is going to be different. Look at the overcome protection device. The same thing. 43. No multiplication. Take it to the same table. What's the next standard?
Up is 45.
45. 45. Up. Always up. 45. So had this been a non-continuous, I continue to use number 6 conductor, but the overcome protection device can be as low as 45 amps. As low as 45 amps. Can you guys see the difference? No multiplication by 1.25. Okay, let's go use this one non-continuous on the calculator. So what did they say? I started with 43 amps, right? Oops, let's go clean it. Clear. So I have 43 amps. Are you guys with me? 43 amps. Now, because it's non-continuous, I don't have to do set wire size, just wire size direct. Continues to give me number 6, Chad. But you don't multiply it by 1.25. That's a key point.
Who does it tell you to go up in the rule? Does it just not really know?
The overcome protection device, it's really the opposite. The rule of going up is the opposite of you can't load it more than 80%. Continuous load.
I'm just, and then looking at that deal where it gives you the standard ampere ratings. On 240.6.
Well, you don't have to go. Because take this. If you can't load a circuit breaker more than 80% of it, so how can you achieve this rule without going up? If you go down, okay, wait, go down on this one. Take this. Go down on which one? Where we going down? Like if you go to 54, go down to 50 here.
Okay.
Take 80% of 50. What's 80% of 50? 80% of 50? What's my load?
43.
I'm screwed. See, kind of the opposite of 80% of loading a conductor, an overcome protection device. You can't load it more than 80%. The opposite of that. To achieve the 80%, you'll have to go up to the next standard. Does that make sense? Kind of reverse function? If that makes sense.
No, I just thought it would be written.
Written somewhere. No, it's not written, at least the way I understand it. You can argue that it's for conductor wise, it's if you go to 240.4b3, it tells you you can use the next size up on a conductor, but this is really not, we're talking about load here. So okay, now I'm going to use the same example just to give you an idea. The same example, if we're going to put this feeder in Arizona in a 50 degrees Celsius, right outside. Good? We're going to size. We're always going to start with a load. Always going to start with a load. Always. And I'm going to size a cable. And we're going to put my cable in 50 degree. The only thing that's going to change is the cable. Because the overcome protection device, guys, it's going to be sitting inside. So it's not going to be affected. So let's take the same example. So that will be example number 7. Example number 7. Same example. Here's my load. What is it? 43 amps. And I need to size this. Number 1. This we already sized it, guys. What was the based on continuous load? And this is continuous. Continuous load. Based on this one, continuous load, that was 60 amps, right? Based on continuous load. And based on based on the size that I came up with, that was 3 conductors, number 6. Okay, I'm going to take the example continuous load non-motor. The example that with continuous load non-motor. This example, I'm going to take this and go put it right in Arizona. Put the feeder and put the ambient temperature different this time. I'm going to put the ambient temperature different. Before I do anything, Phil, I want you to look at this. And if you guys want to listen, you understand this one, you have to listen to what I'm going to say right now. Whatever the derating gives you, you shall not end up with a conductor less than number 6. Did you guys hear me? Whatever you derate, when you derate and size a conductor, whatever you come up with, it shouldn't be, if it came up with something less than number 6 rules. Because that's under normal condition, that's how you're going to size the system, if there's no derating. Derating is abnormal condition. You should come up with a larger conductor, not a smaller one. A larger conductor, not a smaller one. Put this in your mind. So I threw this one in front of you because whatever you come up with after you derate, guess what? You're not going to be using less than number 6 anyway. So let's go ahead. Everybody got that one? No matter what we come up with when we derate right now, I shall not use this than number 6 because that's a normal condition. Okay, let's go put ourselves in Arizona and put yourself in a 50 degrees Celsius. Problem with that? Right? Typical. 50 degrees Celsius. I'm in Arizona and I put myself in a 50 degrees Celsius. Or, you know what? It doesn't have to be in Arizona. It could be in a room that the temperature is so high in it, furnace or something, and I'm using this type of a 50 degrees Celsius. 50 degrees Celsius is hot. And I need to size, so what do I need to do, guys? I need to size a conductor based on a 50 degrees Celsius situation for a machine. Any problem with that? Right? Isn't that typical what we do? Size it based on temperature different than 30. Everything that we size so far, 30 degrees Celsius, right? What we size right now, number 6 is based on 30 degrees Celsius. Now we up it 20 degrees Celsius, a lot of Celsius. Okay, so let's go size it. Here's what you're going to do. By the way, this stays the same, so we're not going to mess with that. The overcomputation device stays the same, 60. All right, so start with the load. So I'm going to be basically, and the question is size, branch, circuit, conductors. Conductors under these circumstances. These are different circumstances. We already sized it, number 6, Chad. I put it different circumstances. Go ahead and start. Take this, take the 43. Now, the derating factors, before you do anything, you need to find the derating factor for 50 degrees Celsius. The question would be, Chad, what insulation are you using? Now we're talking insulation. Because we derate, the word insulation start big deal. So I'm going to be using, I need to go to 310.15. They changed the name on me. That table, the 310.15, B2A. B2 and A. And the insulation is T, H, H, and before, because I chose THHN, the most typical insulation you're going to encounter. Okay, so can you guys find me the derating factor based on 50 degree, based on this table 310.15 B2A? That will give you 90, by the way, that will give you 90 degree, right? Everybody knows the reason why I gave you that, because this means 90 degrees Celsius. 90 degrees Celsius. Okay, so what's the derating factor for 90 degrees Celsius? 0.82. Anybody disagree, with my friend? 0.82. So this is, that will give you a 0.82. My derating factor is 0.82. Any question about that? Piece of cake. Piece of cake up to this point.
Where's that?
310.15 B2A. This is in page 150. Page 150 in NEC code book. Page 150. Cool? Everybody's there? If you don't know how to use this table, please learn how to use it. If it's 60 degree rated temperature, you go to 60, 75, 75, 90, 90. Based on the insulation. How do I know that THHN is 90 degree? You have to go to 310. Or is it? Where you no, it's they moved it away in 2011. 310.10 something. It will tell you that the insulation is rated for 100 degree or so. Where am I here, Chad?
310.104.
Thank you. 310.1048. 310.1048. Thank you. Table 310.1048. That's a table which tells you that's 90 degrees. Okay. Now, any question about this? Now let's go for size. We need to size. I have a load. Here's what you do when you have a load. You're going to take the 43 of it, divide it by 0.8. Untie everything. I don't know if you guys have done that. When you have a conductor and you need to find the load, you multiply by the derating factor. This is not what we normally do. We have a load and we need to size the conductor. So you divide by the derating factor. Very, very important. Load, divide, conductor, multiply. So I have a load. I need to find a conductor, which is 99% of the time, right? You're designers. So what's the answer?
52.4.
52.4 amps. 52.4 amps. Okay? Any question guys up to this point? 52.4 amps. 52.4 amps. Okay. So now next, you got that one? 52.4 amps. Now take your 52.4 amps. Now you're going to take it to 310.15 B16 under 90 degree column. Anybody tell me why am I going to this table under 90 degree column? Because we're derating. The only time you touch that table is under derating. Can you guys find me a conductor that can carry 52.4 amps under this table? Under this the column. Copper, of course we're doing copper, right? So I have 52, it's going to be number 8. Everybody got number 8? Everybody got number 8? So it's going to be 3 conductor number 8. 3 conductor number 8. 3 conductor number 8. What did I say, guys, at the beginning here? We came up with number 6. Which one is larger, 6 or 8? 6. No matter what did they say at the beginning? No matter what your derating come up with, you cannot use less than what the normal condition tells you. That's the catch on the master exam here in Minnesota. They give you an example like this. After you derate, you end up with a number that's smaller than the number of the normal condition, which it could be because of the tables. So what's the rule then? You cannot get less than number 6 because it's continuous load. So go back again here. So yeah, we derate, yeah, we came up with number 8 here, but guess what? The rule, so I'm not going to use this. So it continues to be 3 conductors, number 6 is my choice. 3 conductors, number 6 is my choice. Okay, now let's go try to do this in the calculator, see what the calculator, I've never done it in the calculator. So let's go do it. Yes?
Can you say the reason why you must go back to Ampacity?
Because the normal condition is no derating. That's what you size if there is no derating. The derating is supposed to give you a larger conductor, not a smaller one. A larger conductor, not a smaller one. Like voltage drop, guys. If you do a voltage drop calculation, the voltage drop is supposed to give you a larger conductor, not a smaller one. So if you do, I'm going to show you an example where you do a voltage drop calculation and you end up with a conductor smaller than what you normally do because the length was small. So what do? You're going to go to the normal condition. Normal condition, no derating, no voltage drop, continuous load. That's why we size it. Whatever you do after that based on voltage drop sizing or based on derating, it should come up with a larger size conductor, not a smaller one. Not a smaller one. Okay? Let's go use this one in this calculator. I want you guys, because we haven't done that before.
So even if you're derating due to extremely low temperature, still, for example, if you're running through a freezer.
So can you get more amps?
And the lower the temperature, the greater the.
Yes. No, you're gonna continue with the Yeah, be very careful. Very careful. You end up with a conductor, a smaller conductor, but not smaller than a normal condition. Very good point. I've never done it that way. The bottom, look at it upping. I don't feel comfortable doing a smaller conductor because of temperature. Take it at the normal way, higher conductor, not lower. Okay, so let's go use this calculator, guys. So here's how you do that. Do you guys remember what the situation that we have is? Our situation is we have 43, what is it, 43 amps, right? I have 43 amps. First of all, put your 43 amps. Okay, up to this point, nothing happened. It's copper. I'm defaulted to copper 60. Put your 43 amps. Now, the ambient temperature is different. This is, you have to be very careful if you're going to use this calculator. The ambient temperature of the calculator is always 30 degrees. Now we're going to change the ambient temperature for the calculator. So listen and watch me carefully. You're going to get your 30. I don't want 30. I'm sorry. I'm going to clean that one. Clean again. I'm going to start one more time. So I have 43 amps. Here's my 43 amps, right? I need to change the ambient temperature to 50. What's the ambient temperature? That's screwed up big temperature. So type 50 now after you put your amps. And look what you're going to hit. You're going to hit, do you guys see set and 2? Set 2, I changed the calculator to calculate based on ambient temperature of 50. That's, if you leave your calculator like this, if you don't do the step that I'm going to do right now, after that you screwed up all your calculation. You basically went into the brain of the calculator and told it, I change all the sizing that you do for my cables, now change it based on 50. Cool? Okay, so step number 1, change the ambient temperature. Step number 2, I need to tell the calculator, because I'm derating, that the conductor temperature is THHN. The calculator doesn't understand the THHN the way it's done. You have to enter the THHN is 90 degrees. So I'm going to go hit, set, and 90. So what you did, can you guys see that? I told the calculator that I am using a 90-degree rated cable right in here. So everything that you do, please size based on the column 90 degree, single phase, care less about the single phase, 90-degree column, and the ambient temperature 50. Ambient temperature 50. Cool? Everybody's okay with that? All right, now let's go hit the wire size. Wire size. Number what?
8.
Number 8. Got the same number. But what's the problem with this number 8? The calculator doesn't tell you that. What is the problem of number 8? Number 8 is you can't use number 8 because because continuous load we came up with number 6. 6 is the minimum that you can use. Cool? Any question guys about that?
So then you can just do continuous load, or the 1.25, and then it'll come up with 6. If you set and the 125.
If you size based on continuous load and the rating, you come up with number 6. Yes. But here's what I do, at least personally. I size based on continuous loads first, put it aside, then go do the rating. Bam, 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 the rate, and you choose the one that's larger. You don't do both of them at the same time. You end up with a bigger size conductor later on. Because now it's taking the 54 amps and derating that amps, upping it. So first size based on continuous load, find the conductor, then go for size based on the rating, and choose the one that's larger. Let's make this more interesting, guys, and go add more current conductor. And I know you are due for lunch. I'm going to add one more component and I'm done. I'm just going to add conductors to the same example to tell you how it's going to change. So take example number 9. Example number 9. The same example. And the reason why I like to keep the same example, guys, 60-degree column and 43 amp, non-motor, and continuous. And I will remind you that was number 6. Okay? Take this. I'm going to do two derating now. Two derating. Number 1, let's go get you a few conditions here. Condition number 1, I have a 60 degrees Celsius circumstances screwed up. 60 degrees Celsius. And I decided to put these cables, that number 6, with another 9 conductors, 3-phase each, in a big fat 2-inch or 3-inch conduit. So can I put number 6 conductor 3-phase, 3 of them, with another say 9 conductors, number 4 and number 6, and size a conduit that carry all of them? I can, no problem. So I decided to have how many current conductors? 9 current carrying, and you guys, when I say current conductors, everybody knows that, right? 9 carrying, 9 current carrying. Okay, I grouped it with a 9, all of them together, including the 3-phase here. They were in a conduit where I counted all the phases. I have 3 3-phase circuits, 3-phase circuits, 3 phase with every circuit, so 3 times 3, 9, right? All carrying current. Now I need to do double derating. I need to do double derating, right? Let's do double derating. Okay, do me a favor. Number 1, the same thing, you're going to take the 43 amps, divide it first. What's the 60 degree? THHN. We're using THHN. THHN conductor. Okay, what is the 90 degree, 60 degree, guys? 60 degree ambient temperature. Everybody came up with 0.71? Anybody came up with something different than 0.71 for 60 degrees Celsius? Anybody come up with something different than 0.7? This is from table 310.15b2a. 310.15b2a. Right? Phil, I'm looking at somebody to agree with me, right? It's 0.7. So take 0.71 times. I am building my amp, derated, it's called derated amps. I'm building my derated amp. Based on temperature, my first derating number is 0.71. Based on 9 current conductors, let's go to the 9 current conductors. If you go to 9, my derating factor is 0.7. Everybody knows where to find that? If you don't, you should know it's 310.15b3a. 310.15b3a. What's my derating factor for 9? 0.7. So multiplied by 0.70 equal. See what I did? I took my amps and I divided by, the first time I divided by 0.71, and the second time I divided the answer by 0.70. Or, if you know math, of course, when you divide the same quantity by 2 things, it's like multiplying the bottom and dividing that number by the 2 of them. Okay, so you take the 2 factors, put them here. I need to calculate 2 people to give me the answer for this baby. Now we're doomed because it's a lot of derating here. How much?
86.
86.87. So we came up with 87 amps. Now we're talking. Now we're doomed. Can you guys see how the amps become the derated amps became so high? Because now I need to size the conductor based on 87 amps. Cool? Everybody, Phil, did you guys come up with the same number like my friend Chris? Okay. Up to this point, everybody should know how to do that, guys, before when you're derating. That's not a new topic for you. You take the 2. Engineers and designers look at the load, not the conductor. You don't find a conductor to guarantee how many current I can pull out of this baby. You put the conductor. You always start with the load. I know when we teach you guys derating, probably with Gary and elsewhere, they derate this conductor to this and that. Wait, if you find it, we don't have the conductor. We are creating the conductor. So we always start with the load, instead of going right to left, we go left to right with the sizing. Okay, the same answer, by the way, the same method. 87%. Let's go size based on 87. Are you guys with me? Take the 87 amps. You're going to take it now to 310.15 B16 under. It's a THHN, so it's going to go under 90 degree column. What's the size? Cover. Number 4. Anybody came up with something different than number 4? Number 4. Anybody came up with different than number 4? Number 4. So number 4. What was the size before? What was the size before? The size before was number 6. Is this size larger than number 6? Yes. Am I okay? Yes. That's the key point. This method should give you a size larger than what you normally use. If you end up with a size like we did, smaller, you would never use that. Okay, let's use the calculator to get the same answer. See if we can get the same answer. Would you? All right, let's start the following. This is going to be tricky here. So number 1, clean, clean, clean. By the way, Chris, can you see what it says amp here? If you see the word amp here, that's bad news for you under normal condition. It's telling you you're using a different ambient temperature than what we need to rate for. Here's how you get this straightened out. Can you guys hit set and go to clear, which is the X. Okay, so you need your calculator to reset your calculator. When we're done with this, reset your calculator, otherwise you screwed up with your calc. So hit set and X, which is clear all. It gives you 2011 NEC code book. It defaults to 30 degree, cover 30, 3-phase 60. That's where you're going to be. Everybody's there? Cool? All right, let's go take our amps. What was our amp here?
Where we started or where we finished?
No, we're going to start with the 43 amps. Right there, the amps. I'm going to start with 43 amps and put the amps, right? Okay, did I put my amps? Yep, I put my amps. Now, I need to change the ambient temperature. The first thing I need to do, change ambient temperature to what? To 60. Here's my 60, right? 60. And I'm going to go change my ambient temperature, set and ambient. So I'm telling my calculator that my ambient temperature now is screwed up with 60. Cool? The second thing you need to do is change the insulation. My insulation, can you guys see my insulation still says 60? I'm defaulted to 60. So I need to go change my THH to THHN. So you change that one by hit set and change then one to 90. So I change the insulation to 90 degree, which is THHN. I change my ambient temperature to 60. So your calculator should say 3-phase 90, cover amp 60. Cool? Let's go size the conductor based on these conditions. We haven't done the bundling yet. We have not done the bundling. So go hit wire size. So here's your wire size based on just the temperature. Just the temperature. Okay, cool. Hit the wire size based on the temperature only. But we know we have more than temperature. We have also how many conductors carrying current? 9. So you're going to type 9 after you hit wire. Type 9. Are you with me? And you're going to hit set. And do you see D/R size? This is the rating size. Right here. And up you go with number 4. Did we come up with number 4, guys?
Yeah.
Number 4. So it agreed with us, huh?
What was that button?
The button that you hit is set and parallel size. Set. Every time everybody's know what when you set everything blue here, you access it by hitting set first. So set D/R size, D rating size. So that's how we size based on the rating. It's very important to do the message. I was monkeying around with it. It's very important to do them in order, guys, first. You put your temperature, hit size first, and then you go put the current conductors and hit set D rating size. In that order. So number 4 copper. Now I change my mind. I need aluminum. Okay, I think it should set aluminum. I give you number 2 aluminum. Should change it, switch it right away to aluminum. Set copper, set aluminum. So you can switch right there when you do rate. You do rate based on aluminum, based on copper, you name it. Now, when one of you guys sit for your master exam, or they don't use it, but say if the conductors are outside, so I can't use 90 degree because it's THW, and if you use THW or THW outdoor, it has to be rated for 75. So suppose I want to rate everything for 75. Look how easy that is. Suppose it's outdoor, I want to do it for 75. All what you have to do now is set and hit 7. Now we're sizing based on 75 derating. We are sizing derated cables based on 75. piece of cake. Does that make sense, guys? Because sometimes if you have THHN/THW, most of the installation has THHN/THW. So if the whole scenario here, which is 60 degree, and the 9 conductors in one conduit sitting on the roof, could it be? Easily. Now the roof, you're going to agree with me, wherever you go, even in the desert, it rains, so it could be wet location. Wet location, then it's THW. THW is rated for 75. When you derate, you have to use the 75. How do you use the 75? You hit right here, set 7, size based on 75, and if God forbid you want to size TW, if you're using insulation TW, which is sizing, derating based on a 60 degree, God forbid, you're going to end up with set, and where's 60? None. Doesn't allow you even to go that far. Did they hit anything? 75? It doesn't even allow you to go to the 60, the rating, because it will be not a good idea to derate based size derated based on 60. Doesn't allow you to even go there, the calculator. But you can though. Any question, guys? If you want to know how 60, take the 87, go under 60. Let's go to 87 under 60, 87. That'll get you number 2 actually. 95, that'll get you number 2. I don't know why the calculator is not giving it set based on 60. None. They don't want you even to mess with it. 6, which is most of the time true, guys. The worst that could do is derate and size based on 75. Derate and size based on 75. 99% of the time when you derate, you're sizing based on 90. Exactly what we did. Any question, guys? See how nice the rating is? Nice. Is it nice, Chad? I can't emphasize, and I know you're due for lunch here. I can't emphasize one little thing before I let you guys go. When you derate, there are 2 methods. The engineering, not 2 methods, 1 method, 2 ways of doing it, applying it. When you design as a designer, and as an electrician too, you start with here's my load and here's my conductor. So if you are going from load to conductor, you divide. If you're going from conductor to load, you multiply. Always write yourself a note if you haven't seen this before. If you have a conductor and I ask you how much current you can suck out of this conductor, so where am I going? Which way am I going? Conductor to load. So what do I do with the derating factor? Multiply. If I'm going the opposite, I have a load. Here's my load, and I need to power that load with a cable. So here's my load going to where I need to find a cable that can tie to this load, which is 99% of what you guys are going to be doing. Have a load, a machine, you need to tie it to the system, right? In a case like this, we have a load, we're going to conductor. What do you do with the derating factor? Divide the load by it. Okay, please write yourself this note. It makes your life and mine easier as we move on through the year. Okay, based on what we did today, guys, I'm not going to be able to get you a test over the weekend because I need to cover a couple of other things. So our test will be next week then. I will continue talk about derating. I have tab rules I want to go over tomorrow. And tab rules are very important. And take a couple of more examples on the calculator, how to do derating too. And then we're not going to be able to take a test. So be it, we're not behind. I know you're not going to sleep tonight, Chris. Okay, that's all I have. Any question, guys? And for those of you who don't have a calculator, my apology, guys. I didn't make this is the first year that I ever incorporated this fully in our calculation. We bought it. I thought it's a good idea to know how to use it as we go through. So, thank you.